Yeah, good evening. You can join now. I have given the recent link actually. Anyone is in the class now? You can join this stream now. Just send me your name. I'm going to see that in our name the chat box before starting the session. Just send me your name. Yeah, another 2-3 minutes. I'm going to start the session. Just in the chat box, just say hi. Yeah. Yeah, dear students, whoever joined, please just say hi in the chat box. Within 2-3 minutes, I'm going to start the class. Yeah, hi, sir. Yeah. I think I can inform other students there in the other group. I think I don't know that it is not enabled to work that live session. Before that, I was trying that. Now, yes, I'm going to start that. Please inform to other students who are in the other classes now. I think they are in the other window. I think just inform that due to some network issue, I have started late. Now, I will continue the topic. Yes, in 2 more minutes. Please inform the students they will join now. Just 1 minute, I'll join now. I think the people are waiting in another group. Yeah. Just a few more minutes, I will start. Yeah, students, please help me. I think some people are in other group. I think just you can update in our groups. You can update them. They will also join. They're waiting another group, I think. I'm also trying. Please inform them they will join. So in those three, you can inform two students. They will join now. They're another group, I think. Yeah. Dhanusri, you can inform to the students. The before link is not working for me. I tried that, it is not working. You can inform, they can come back to this. In those three, you can inform to other people in the group. Mustafa, inform to the students, they will join now. Because more people are waiting in another platform. Yeah, you can inform. In the group, you can inform. In these three, inform our group. You can inform. Sorry for the delay today. So the network issue only. You tried other group, I think, right? Yeah, they're waiting other group. That one problem, I don't know, it's not working that for me. I tried. I think they can come back. They should come back to this. They can join here. Fine. Then I will start the class. Now, basic thing before the other people will join, please inform them they will join. I think little confusion today. When I schedule, it's not working for my side. Yeah. Yeah, Yuvraj, inform others in the group. Please update in the groups. Inform that they will join now. Okay. You can send the link also. Please share the link. Please share the link in the group. You share the link. Please share the link. They will join. Everyone will join. Please share the link. Industry, you can also share the link in second year. Please share the link. They will join now. Even share to me the link. You can share to me also. I will share in the regular Chavara group also. I should share to regular Chavara also. Yeah, even you can share me for me also. Anyone. Anyone, please share me the link. They shared here. Okay. Then I can share to Shower Academy. Yeah, fine. Okay, anyhow, I'm going to start the class. Now the topic is play with graphs. This is the most important concept in JE level and advanced level. This most important concept. We should be thorough with this. In the first session, I'm going to explain what type of functions will be there. What are important functions? I'm going to discuss about what type of functions are important. First, I will discuss. Today, few topics I will clear. So almost I required 4 sessions to complete all the play with graphs, 4 sessions. like 45 to 1 hour session. 4 sessions I will take. I will try to complete. After completing all this, one more session will be how to solve different types of equations using the graphs. That also we will do one more session. Here, the most important thing is in the functions. This is a major topic. In the functions, if we consider functions, in functions we have two types of functions we have. In the functions, two types of functions. One is algebraic, another one is transcendental functions. We have two types of functions, algebraic and transcendental functions. So mainly, if you take any function, we have two types of functions we have. So always remember. So transcendental and algebraic functions. These are the two types of functions we have. In that, now in algebraic and transcendental. So here, when I'm considering in algebraic, so polynomial function, rational function, irrational function, and piecewise. So these are the four types are there. Repeat. Mainly we have functions. In these functions, we have two types, algebraic, transcendental functions. In algebraic functions, again, we have subcategory. So in that see here, in algebraic, polynomial, rational functions, irrational functions, piecewise. Total, we have four categories, polynomial, rational, irrational, piecewise. Four types of functions we have. Repeat, in algebraic, polynomial, rational, irrational, piecewise. Again, in piecewise, modulus function, signum function, greatest integer function, least integer function, and fractional part function. So these are the types we have. Fractional part function. I will repeat. So these are the categories in algebraic, total 4 mainly. In that, mainly we have important one, fractional part function, least integer function, greatest integer function, signum function, modulus. It takes more important pieces, it takes more time. This is one session I will do this. After that, coming to transcendental functions. Transcendental mainly related to trigonometry, inverse trigonometry, inverse trigonometry, exponential, logarithmic, geometrical. So these are the types in transcendental. So in transcendental also, trigonometric, inverse trigonometry takes one session. Trigonometric, inverse trigonometric takes one session. Now here you can see here, what saying here, now you can observe here, in this always you can mention here, trigonometric, inverse trigonometry. Next, exponential, logarithmic, geometrical. So these are the things we have. Now you are in this transcendental. Okay. Now in transcendental, after considering this 5, okay. Coming to now, these are the main picture about like graphs. Play with graphs. Now I am going to discuss about the topic of an algebraic, polynomial, rational. I will try to complete. If time is there, then I will start with irrational functions also. I will try to complete even irrational functions. That I will do that. Now here, coming to the algebraic functions. So first in algebraic, first one under algebraic, polynomial function. So I will discuss about the polynomial function. So what is a polynomial function? If we consider polynomial function, so generally when I am talking about polynomial function, so talking about polynomial function. See in polynomial function, so polynomial function. What is the meaning of polynomial function? If you take any polynomial function, it will be like f of x equal to a0 plus a1x plus a2x square and so on plus anx over n. Here this is polynomial function. Here I can say here n is a natural number. N belongs to n. N belongs to n. A0, a1 and so an belongs to R, real numbers. These are the coefficients of real numbers. N is a natural number. It is a polynomial function. In polynomial function, I will discuss in the beginning some basic functions I will discuss. To learn that, some basic functions I will discuss. In some basic, I will discuss about the basic functions. In polynomial, I will discuss about some basic functions I will discuss. What about the board? Is it clear? Are you facing any problem with the screen? The screen is clear. Is it clear about the screen? Yeah, say something in the chat box. The screen is clear. Yeah, better you take the notes. You should maintain the notes. Better you should maintain the notes. Yeah, is it visible? The screen is clear. It's clear. Okay, fine. It's clear. The screen is clear. Good. Now, the people, anyone is facing with the screen, you rejoin. You can rejoin that. It will be clear. Okay, now coming to this, when I've taken this, all the given a naught events belongs to R. This is the polynomial function. Under that, I'm going to discuss about now some basic. So the basic polynomial functions. So basic polynomial functions, like I can discuss about y equal to x, that is the identity function. First I will consider under polynomial functions, so we will consider some basic polynomial functions. If we go for some basic polynomial functions, so think about some basic polynomial functions. First one I can consider identity function. So I'm talking basic polynomial functions. Basic polynomial functions. Under basic polynomial functions, first I am talking about identity function. This is important one. Identity function. So what is the meaning of identity function? If you are considering identity function, the identity function should be like, you can think about the identity function. Always you will observe here the identity function. Yes, the identity function will be like, here f of x is equal to x. So this is identity function. They will define f from R to R. The function they will define f from R to R. They will define. This is identity function. So if you think about identity function is nothing but y is equal to x. Correct? Will get like this. So this is the basic first one. Y is equal to x. You should know about this. It is symmetric with respect to origin. This is origin. It is symmetric with respect to origin. It is symmetric with respect to origin. I can also say it is symmetric with respect to opposite quadrants. Correct? Y equal to x is symmetric with respect to opposite quadrants. If I hold like this, it will, with respect to origin, it is symmetric. That you remember, it is symmetric with respect to origin. Not only that, you can see here, when I have taken y is equal to x in this function, what about domain of this? So think about domain is equal to R, even range also R, both are same. Domain is equal to R, range also same. Domain R, range R, both are same here. So this is identity function. So that you remember, both are same identity function. After that, I will discuss about square function. What is the meaning of square function? So after identity function, so think about square function. Because these are the basics you should require to learn the graphs. Square function, I can consider square function. So what is the meaning of square function? I can consider f of x equal to x square. I can say square function. I can also say it's a parabola. It represents a parabola. It's a square function. It represents a parabola. This equation represents a parabola. What about the domain of this function? Think domain of this function. If we think domain, so domain will be R here. Think domain is R. When you think about the graph of this, so think about the graph of this. This is called square function, or I can also say parabola. I can also say parabola. Also this one is a parabola. So here in this concept, you can see here when x equal to 0, definitely it will be 0. You take any, we are moving towards x. X is increasing. When x is increasing, the value is increasing. When x is increasing, the value is increasing. When x is increasing, square of x is, the value is increasing. You can see even x is decreasing, but even x is decreasing also, the value is increasing, right? Why? Because square of any number gives positive. The graph will be above x-axis, right? It won't come down. The graph will be above x-axis. When I am taking x square, the graph will be above x-axis. You remember, it is symmetric with respect to y-axis. This graph is symmetric with respect to y-axis. You remember that point. Domain is R. What about range? If you are thinking about range of this function, so range is starting with above 0, right? I can write range will be including 0 to infinity. That means this graph has only minimum value. This graph has only minimum value. Correct? Only minimum value. It has only minimum value. It doesn't have maximum value. Minimum value starts from 0 to infinity. This is domain range of this. Going, this is a parabola, right? Symmetric. Whenever symmetric with respect to y-axis is even function. When the function is even, remember, when the function is even, it is symmetric with respect to y-axis. When the function is even, it is symmetric with respect to y-axis. That is most important. Symmetric with respect to y-axis. For example, if you take just multiply, this is x square. Suppose if you multiply with minus x square, with minus, if you multiply with minus, automatically you can see when you are multiplying with minus, whatever you take the number, the result will be negative, right? The result will be negative. The y equal to minus x square. The result will be negative, right? Automatically the graph will come like this. Downward it will come. The graph will come down, right? Because whatever the value of x, y value will be negative. So whatever the value of x, y value will be negative. It will come downward. The graph will become downward. So now you can see here. So it is 0 only here. What about the domain of this function? You can think domain is, but in this case, domain will be equal to, I can think, again, this is a even function only. The function is even, symmetric with respect to y-axis. Whenever even function you take, even function always symmetric with respect to y-axis. It is symmetric with respect to y-axis. Domain is equal to R. You think about the range of this function. If you go range here, minus infinity to 0, right? It will come maximum is 0. The function has maximum value at 0, 0. There is no minimum. But above this, there doesn't have maximum, minimum will be there. This is, you can see, this is mirror image of this. Just mirror image of that. You can see, let it be, this is the mirror. This is the mirror image of this. It will come here, the image of this. You can think about that. That way you can think about this, quite opposite of this. Now, see, if I am taking this one, you got the result like this, right? Next one. Suppose if you are thinking about cubic function, odd function, you know this is even function. Just I have taken this is even function. If you take odd function, so for example, odd function f of x equal to x cube. So think about f of x equal to x cube. So if you take that is called q function. Like q function means I can consider about q function. So q function is nothing but I can consider f of x is equal to x cube. So this is q function. F of x equal to x cube is the q function. F of x equal to x cube is the q function. So when I have taken f of x cube, since it's an even function, this is an odd function. I can also say function is odd. This function is odd function. So whenever you are taking this is odd function, you can think about the graph of this. What about the nature of this? What about the nature of this graph? See here, when x is increasing, at 0 is 0, it passes through origin. When the graph, there is no constant, it passes through origin. Always it passes through origin. So when x is increasing, this value you can check here. So what is the nature of this graph? Always you can see nature of graph. The graph will be like this, it will come like this. It is going like this. When x is increasing, the value is increasing. When x is decreasing, the value is decreasing here. The value is decreasing here. It will go like that. It will continue, correct? The graph will continue, right? It will be continue. Now you can see here. When I have seen this, you can observe here. Now, is it fine for you? Yeah. Now you can see that is it clear. The graph is clear now. Now, So when I've taken like this, now here what we'll observe here, now when I've taken like this is the graph x cube, the function is odd. The function is odd. The function is odd, right? Now this is the odd function, this is the graph of this one. Think about what is the domain of this function, what is the range of this function. That was you can think, what is the domain of this function and range of this function here. So you can see here, domain and range both are same here. R cube, domain and both are same here. In this function, domain equal to R, range is equal to R. Domain is equal to range is equal to R. Both are same here. Both are same. About the screen is clear. Can I increase the light? Is it required? It's coming blur. Fine. Now domain and range, this is same here. So just remember again, this is also like this graph is y equal to x cube. Again, this is symmetric with respect to origin. With respect to origin, this graph also symmetric with respect to origin. This graph is symmetric with respect to origin. Symmetric with respect to origin. That is important. Or I can say symmetric with respect to opposite quadrants. It is symmetric with respect to opposite quadrants. That is important. Now after this, I am going to complete in general functions. Suppose if I compare even function x square, x power 4, x power 6. How will you draw that? X square we know that. If you think about x power 4, x power 6. So you can think about those graphs here. I am talking about, but this is the cubic function, right? Suppose in general, if we think about in general function, like if we consider f of x is equal to x power 2n, n belongs to n. This is x power 2n. So you can think about the graph x square, x power 4, x power 6, x power 8. These graphs. Think about these are the graphs. Square of this x square, x power 4, x power 6, x power 8. So you can see, think about this graph. How will it be the graph of this? Just I will compare just 2-3 graphs I can compare. You will understand that. So here the value depends on the value of x also. Here you can see 2n and is an even number. The value is increasing. So if I draw the graph of this, you can think about this. If you draw the graph of this, and I'm talking about graph of this. So here you can observe here x square we know that the graph of x square we know it's a parabola. It's a parabola. But when you're taking the values here, you can see before that just I will give about this one. This is y. You know this is y equal to x, right? This is y equal to x. That will be y equal to x. Now you can think at 1 and minus. You can see if I draw the graph of this. So this is the parabola I have taken like this. If it cuts me this value, let it be 1 here. So this will be like minus 1. So it is 1 and minus 1. Why? Because you can think about that more than 1. If I take more than 1, if you take the value more than 1, if I increase if more than 1, you can write x square greater than x power 4 greater than x power. Am I right? These values, right? Is it fine here? You check the value which is more here. If I take that value, x square x power 4. If it is greater than x power 4, x power 6. If you take these values, whenever if you take between 0 and 1, if you take between 0 and 1, x belongs to between 0 and 1. You take, so you can see, if you take between 0 and 1, whenever increase the power, the value is going on decreasing between 0 and 1. Even between minus 1 to 1 also you can consider. Even between minus 1 to 1. You take between minus 1 to 1. You can consider between minus 1 to 1. What will happen? If we rise the power, the value is going on decreasing. For example, x is equal to 1 by 2. 1 by 2 whole square, 1 by 2 whole cube, 1 by 2 whole power 4. When you are increasing the power, the value is going on decreasing, right? the value is going on decreasing. That you remember here. When are increasing the power, the value is going on decreasing. So if you increase the power, the value is going on decreasing. So in the case of between -1 to 1, it will be reverse if it is more than 1. So we can see, suppose minus infinity to -1. If x belongs to minus infinity to -1, union 1 to infinity. If we take in this interval, the value will be reversed. You will get x square less than x power 4 less than x power 6 less than. It will come like this. The values, the position, it will come like this between. The reason between -1 to 1, if I raise the power, the value is going on decreasing. So that's the reason here. When I'm taking this is x square graph. Think about graph of y equal x power 4. Y equal x power 4. Just I have drawn the graph. This is right. This graph is. So this graph is just y equal to, this is x, y equal to x square graph. This is y equal to x square graph. Suppose I am trying to draw the graph of y equal to x power 4. If I draw the graph of y equal to x power 4, if I draw the graph y equal to x power 4, if I draw the graph of y equal to x power 4, so what will be happen here? If we compare at this one 0, 0, the passes here. So the graph, when it comes here, the graph will go like this. So it will come up. Why? Because after this, you can see the x power here, the value between 0 to 1, x square is high, x power 4 is less. It will come down, it will come up like this. Even the graph will come like this. It will come like this. So this is a y equal to x power 4. Y equal to x power 4. This is y equal to x square, right? This is y equal to x square. The inside is y equal to x power 4. Why? Because the value understood here. Between more after 1, the value is increasing. After 1, this is the position. X square less than x power 4. X less than x power 6. So the graph will come inside like this. Suppose you think x power 6. If you think x power 6, the graph will come like this. This is x power 6. X power 6. X power 8. X power 8 again it will come like this. X power 8 it will come like this. This is x power 8. Because at 1 they are intersecting, right? Even this line, x is equal to, this is the line, y equal to x. Passing, this is the point. You know this point is 1, 1. This point is, minus, minus 1. You will get minus, minus 1. So this graph is going like this inside. So this is the related to parabola here. Now you can see these are all here. These graphs are symmetric with respect to y-axis. This graph all symmetric with respect to y-axis. So these are the graphs symmetric with respect to y-axis. So the parabola it will come like here. These are symmetric with respect to y-axis. Now after that, now here the thing is shifting. So but what are the changes in the graph here? This is the most important one now. This is the most important one. The graph of the parabola is important one. So I'm just after this one of learning this. The most important one. Suppose if I take the graph of this one, whatever the graph y is equal to x minus 1 whole square, you think about this graph. Instead of x square, I have taken x minus 1 whole square. What is the graph of y equal to x plus 1 whole square? Y equal to x plus 1 whole square. If I think about the graph of that, y equal to x minus 1 whole square, y equal to x plus 1 whole square. When I have taken this type of graphs, you can see here. When I observed here, y equal to x minus 1 whole square, y equal to x plus 1 whole square. So when in this x minus 1 whole square, you see here, when I have taken here, so this is the graph of y equal to x square. Y equal to x square, this will be the graph of y equal to x square. When you are taking x minus 1, if you take x minus 1, just you move towards, you can see x minus 1 means the graph will go like this. This is 1, 0. How? Why? Because when x equal to 1, y will be 0, right? When x equal to 1, y equal to 0. So it touches the graph at 1, 0. After that, you take more than 1, the value will be positive, going upward only. Even if you take left of 1, there will be positive, upward only. The graph will go like this. You get positive value, you will get only positive value you will get. So this is the graph 1, 0. Now if we take this side, so you can see what about this one, x plus 1 whole square. When they're talking about x plus 1 whole square, then the graph will come here. So this will be, for example, this is the graph. Why? Because here you can do when x equal to minus 1, y will be 0. When x equal to minus 1, y will be 0. When x equal to minus 1, y will be 0. Right? When x equal to minus 1, y will be 0 means if I draw the graph, it will come like this. So it will come, this is minus 1, 0, shifting this side. When x plus 1, you are shifting left, x plus 1 graph. When you are taking x minus 1, you are shifting right. You are shifting right. I think, is it clear? The screen is clear? I hope you are understanding this, the concept, what I am explaining here. Is it clear? In the chat box, you can reply. In the chat box, you can reply. If you have any doubt, even you can ask in the chat box. To repeat, you can ask in the chat box. Even if you want, you can repeat in the chat box. You can ask. I can reply. I can explain again. I can explain. I can explain again here. So this is the graph of this one, x plus 1. So you can see, you can think this is the graph of y equal to x minus 1 whole square. This is the graph of y equal to x plus 1 whole square. Like this, we are moving towards this side. Suppose you think x minus 2 will come here. You can see, like the x plus 2 will come this side. So like this, we can derive the parabolas. We can construct like this. The parabolas will come like this. Now, here again, suppose in parabola only, this is x minus 1 whole square. Suppose if we multiply with x, this one we multiply with x, what will be the changes we will observe? X minus 1 whole square, I can draw this. Suppose this parabola, if I multiply with x, this is the important concept here. Suppose if I multiply with x this one, suppose I am taking this, you learn this graph. See, in what way you learn this graph, you can see here, this graph you got like this. So this is the graph of this one, y equal to, you observe here, x minus 1 whole square. Right? You know this, y equal to x minus 1 whole square. I am talking, suppose, how to do a graph of x into x minus 1 whole square. Think about this graph. This is a combination of x into x minus 1 whole square. So if you think this graph, then I will ask you, they will ask an exam, draw the graph of y equal to x into x minus 1 whole square. Find the image of that, find image of this with respect to y-axis. That will be the question. What they will ask? Draw the, you think, simply they will ask, what they will ask? They will ask, find the image of the graph of y equal to x into x minus 1 whole square with respect to y-axis. Like that they will ask question. One time they ask. Again I will tell you, what is that? What is the graph of y equal to x into x minus 1, the graph, the image of. Think about the image of this graph with respect to y-axis. When they are talking with respect to y-axis, now you can observe here. When you have taken the graph with respect to y-axis, you can see for what value this will be 0. You can think this graph. We can think here when I'm trying to draw the graph of this. When I'm trying to graph of this, that you can see at x equal to 0. At x equal to 0, the function value will be 0. Correct? When x equal to 0, the function value will be 0. When x equal to 1, you can see when x equal to 1, the function value will be also 0. Means at here 0 and here also 0, right? Both the places 0, right? You take any number between 0 and 1. Take any number between 0 and 1, it gives positive. Is it right? You take any number between 0 and 1. 0 and 1, it gives positive. The value is positive. That means the graph will come like this. Correct? If it is negative, it will come down. You take any number between 0 and 1, you verify. Take any number 0 and 1, it gives positive. After that, more than 1, you take any number. If you take more than any number, you take more than 1. More than 1, if you take, it gives positive. The graph will go like this. It will go up. Because if you take any number more than 1, it gives positive, right? But coming to negative, when x is negative, this part is positive, positive and negative. When x is negative, so the y value is negative, the graph will come like this. It will go like this. So this is the graph of y equal to x into x minus 1 whole square. We can consider this is the graph of y equal to x into x minus 1 whole square. So you understand this one. They are asking what is the image of this graph with respect to y-axis. That they are asking. Image of this with respect to y-axis. Think what is the image of this with respect to y-axis? You can think this is the thing. When they are asking image with respect to y-axis, so the graph you can think with respect to y-axis how it will reflect. So when they are thinking, I'm talking, this is the graph of this. I want image of this. Image of this means when I'm asking image of this will come same thing, it will reflect here. This is minus 1 comma 0. It will reflect here. This line will come like this. Correct? Image, I'm talking about image of this graph. It will reflect like this. This line it will come like this. Correct? Actually, the given equation, this is the graph. Y equal x into x minus 1 whole square is the given graph. This graph we got like this. In the exam, they asked one time, what is the image of that? So this image of this graph is this. Understood? With respect to y-axis, I have drawn. So this is image of that. Clear? This I have drawn here. Image of this graph with respect to y-axis is this one, the dark one, right? This one, right? That will image of that. We got that one. Now, is it clear? Again, suppose if you multiply with minus x, what will be the graph of that? You can see here. I'm talking about this one. For example, I have taken y is equal to minus x into x minus 1 whole square. What about the graph of that? So you can see this is x minus 1 whole square. This is a x into x minus 1 whole square. I have drawn this. Here I have two are there. This side graph is this side. You can see this is observe here. Don't confuse here. I have written here. What I asked the question here. You remember here. I asked here image of this one, right? Image of this one with respect to y-axis. So then this will be this. You will have this graph. The dark line is image of that I have done. Suppose the equation is y equal to minus x into x minus 1 whole square. Then how will you draw that? That I am going to explain now. Suppose just very simple that one. So they are asking. So this is important concept to learn. Most of you will confuse here. They are talking about y is equal to minus x into x minus 1 whole square. When I have taken this. Now you can see. When I have taken this is positive, right? Opposite of this. First, you draw the graph of it positive. You can think just when it is positive, I got suppose when x is positive, we got the graph like this, right? Just now I explained. Correct? When it is positive, graph like this. This what I explained. When x is positive, correct? When x is x into x minus 1 whole square. When x is positive, this is the graph of this. I told like this here plus x are given. When plus x are given, I told here between 0 to 1 positive. Even after 1 it's positive, but when x is negative, the graph will come like this. But when I asked at minus x, see this is the problem. Well, very simple. When they are given minus x, you can see between 0 to 1, you can observe here. They are talking about between minus x, they are asking here. You can think about that. 0 to 1, if you take any number here, you can observe what will happen here. You can observe that one graph. If I do that, what are the changes here? Otherwise, before minus x, I have taken just minus x. You can think about minus x. If I take this is plus x is like this. If you think minus x, now you can think about the minus x graph. So that will be reflection of that. It will come. Minus x means opposite. So this is if I take minus x here, the graph will come reverse like this. Why? Because when minus x, so if you take minus x between 0 to 1. If you take between 0 to 1, whatever the value you take, it will negative, it will come. So automatically when it is minus, instead of this, it will come down, right? Image of this, it will come down, it will come like this, between 0 to 1. See the graph of the reverse, it will come 0 to 1, reverse. And again, if you take more than 1, even if you take more than 1, you can see, if you take more than 1, you will get the negative value only. So the graph, instead of this, you will get image like this, it will come like this, to remove this. So it will come like this, correct? I will get like this. Why? Because negative, it will come like this. So observe the graph minus of difference. This side I have drawn the graph x into x minus x into x minus 1 whole square. It will come like this. Again, the thing when x is negative, this will become positive. Correct? When x is negative, y will become positive. X is negative, y will become positive. The graph will come like this. That will be the graph you will get. This is a graph of minus x into x minus 1 whole square. So I have doubt. Suppose instead of minus x, if I write x square into x minus 1 whole square, what will the graph of that? If I take the what will graph, this is most important. So here, suppose this is x square. Correct? You can observe here the comparison. Again, see here, when I have taken this graph. So now, see all the types of graphs you can see, just simple changes. When I have taken y equal to x into x minus 1 whole square, this I explained. This graph is, I got like this, right? This graph is, this is the graph, right? This is the graph I got. Y equal to x into x minus 1 square whole square, I got, this is the graph. Now here, what I am asking, suppose I want y equal to x square into x minus 1 whole square. Y into x square into x minus 1 whole square. If I want this graph, so what the changes if I do here? So I want only square of this. Square of this is very simple. Between 0 to 1, you can see between 0 to 1 the same thing. You can observe here, the graph here. Between 0 to 1 is increasing. It will come like this. Even 1 comma 0 increasing, it will go up. Even x is negative, it's positive. It will come like this. So that means here only changed. When this is x is positive, set same. When x is negative, x square will become positive, right? So the reflection, you will take it up. Instead of this, you move that side. Correct? You move that side, that's all. Here y negative, right? But here always positive. Move upward. Move. Only you take just you this line to take it up. Other part is same. So that will be y equal to x square into x minus 1 whole square. This is 1 0. This is 0 0, right? This is 1 0. I am teaching the basics. These are the questions they are asking in the JEE level, advanced level. They are asking most important concept. This is the basics you should learn. How to shift, how to do that. Like how the change will come compared to these two graphs. The comparison you should learn always. Better to comparison, you to learn. That's easy to learn. If you go for comparison, easy to learn. Now, another 5 to 10 minutes, I am going to complete the session, today's session. Now, if you take another one, so I discussed about like this, some basics. Still, next session, we will do very wonderful graphs, we will draw that. So, different concepts we will do in the next session. So, this is the basic now. Suppose, if you think about any odd function, I told x cube is called odd function. It is symmetric, x cube is odd function. That the odd function always symmetric with respect to origin or opposite coordinates, right? That we discussed about that. Symmetric, opposite coordinates. I told for example, f of x power 2n minus 1, n belongs to n, that given like this. 2n belongs to n belongs to n. So this is an odd function always. Remember this odd function, this one. X power 2n minus the function is odd. If you take this function symmetric with respect to origin, or you will get opposite coordinates. For example, you take this function here, I can consider here. For example, f of x equal to x cube, you can consider. This I explained, x cube. It is symmetric, you can see here, this odd function, right? So I have drawn this function. This is odd function. I have drawn this one. It is symmetric with respect to origin. Correct? Now you can observe here. The thing is always, the major important point is minus 1 to 1. This is important point, minus 1 to 1. Minus 1 to 1. That is important. Between 0 to 1, if I raise the value, x1 is increasing. So whenever I raise the power, decreasing, right? X cube is decreasing. Whenever I raise the x cube, decreasing. After 1, it increases, right? So remember, if you take 1 comma infinity, see in this position, 1 comma infinity, you will get x less than, x cube less than, x power 5 less than, and so on. The values between 1 to infinity, x cube, x power, if I raise the power, value is increasing. Value is increasing. If we come here, another one, 0 to 1, you think between 0 to 1, what will be the change here? Think between 0 to 1. If you think between 0 to 1, x greater than, x cube greater than x power 5. This is obviously right. Between 0 to 1, if we take the value of x greater than x cube greater than x power 5 greater than. Why? Because the rise of power while is going on decreasing between 0 to 1. Suppose whatever between minus 1 to 0. If we take even minus 1 to 0, when let's say it's negative. So it will come again x less than x cube less than x power 5 less than. You can observe the value. Take one example, you can consider that. Suppose if we take minus infinity to minus 1. To take minus infinity to minus 1. If we take minus infinity to minus 1, again the opposite you will get x greater than x cube greater than x power 5 greater than. These are the values it will come. So keep in your mind when you're taking any odd function graph. So if we draw the graph of this one, suppose if I draw the graph of x power 5. See, if I draw the graph of x power 5, it will come like this. This is x power 5. At 1, this is 1 means I can consider this is 1. So I can consider this value wherever they're intersecting, I can consider minus 1. So this is, you can see here, this graph is y equal to x cube. This is y equal to x power 5. Following these conditions. So you can see this is the graph, it will start like this, it will come like this, passing through this, coming downward. Why? Because between 0 to 1, you can check between 0 to 1, check the value, x greater than x cube greater than x power 5, x cube is more, so the graph will come up, x power 5 is less, it will come like this, even if you draw, you can see x value, if you draw the graph, x is also odd function, right, y f of x equal to x, this is also odd function, right, if you draw this, you can also see, this graph will come like this. This is the y equal to x. The graph, this is y equal to x equal to the graph. You will get this is y equal to x. Right? It will come like this. Because you can compare all the values between 0 to 1. Between 0 to 1, x is more. But the x will be graph is upper. Correct? X graph will be more than this. If we increase the power between 0 to 1, the graph will come down. X power 5. Suppose you take x power 7. If I take x power 7, still it will come like this. X power 7, it will come like this. This is x power 7. X power 7. You can see here, I can write this is x power 5, x power, this is x. So just to think about the graph of that. Just when you're drawing the graph of odd function, remember these concepts. You should remember. After that, another 5 more minutes, I'm going to complete rational function. In that rational function is reciprocal function. That will be, I will session this today's session almost I'm going to complete that with rational function. I will write that. Think about the ratio. What is the rational function? Just 5 more minutes. We'll complete the rational function. So what is the rational function? So we completed polynomial function and coming to the rational function. So if we take rational function, just think about rational function. If we take about rational function, they will define before what is a rational function. So suppose here, if a polynomial is divided by another polynomial, then that is known as rational function. I can write p of x by q of x, where q of x not equal to 0 is called rational function. Here, what is the domain of this function? Think about domain always equal to here r minus x such that q of x equal to 0. Why? Because whenever the value q of x equal to 0, you remove from r. This is the domain of this function. This is the rational function. The most important concept in the rational function, we will take f of x equal to 1 by x. This is the most important one. F of x equal to 1 by x. When I have taken f of x equal to 1 by x, you can observe here, when I have taken f of x equal to 1 by x. So you can see here, f of x equal to 1 by x. What is the domain and what is the range of this function? What is the domain and range? You can think domain equal to r minus singleton 0. Even range also same thing, r minus singleton 0. Domain and range both are same. There is no change here. This is the function. What is the graph of this one? This is important here. They will say here this graph reciprocal function, or they will also say rectangular hyperbola. They will also say reciprocal function, or they can also say rectangular hyperbola. If you draw the graph of this, you can observe here. What about the nature of this? What is the nature of this graph? Reciprocal function. So you can see when x increases to infinity, when x is increasing to infinity, function is approaches to y because y equal to 1 by x. When x approaches to infinity, then what about y approaches to 0, right? Y approaches to 0, even plus or minus. Correct? You will get x approaches like this, you will get like this. This is a reciprocal function. So how can you decide these positions here? Why? Because you can see when x up to plus or minus infinity, y approaches to 0. But you can see here, when I'm talking about the value here, this is 0. When x approaches 0 towards this side, x approaches to 0 from right side, the function approaches plus infinity. When x approaches to, you can see, whenever x approaches to 0 plus, what is the notation of 0 plus? You are approaching 0 from right. You are approaching 0 from right, then the function value approaches to plus infinity. It approaches plus infinity. Same time, when your x approaches to 0 minus, you are approaching 0 from this side. You are approaching like this. You are approaching 0 from this side. Automatically, when you are approaching 0 from left, when approaching 0 from left side, you are approaching 0 from left, you are approaching from left side, you are approaching, then y approaches to minus infinity. So that's the reason the graph will come like this. This is a common point here. This is the point will come 1, 1. And this is the point will come minus 1, minus 1. This is called rectangular hyperbola or reciprocal function. Again, one more thing we can also accept here. What is it? Can I say here? What can I accept here? You can observe here. You can see if you compare these two. If you compare these two. Again, this is one is the image of the other. Correct? You can say here. Again, this is symmetric. This is symmetric with this is odd function. Remember, y 1 by x is odd function. This is symmetric with respect to origin. Or I can also say opposite coordinates, right? It is symmetric with respect to opposite coordinates. Remember, it is symmetric with respect to opposite coordinates. I can also say this is an odd function. This is an odd function. Suppose if I take 1 by x square, 1 by x square, what will be that? If I take 1 by x square, right? The 1 by x square means you can think the domain will be r minus 0. What about the range of this function? So think, I'm talking about 1 by x square. So domain will be no change, right? 1 by x square, right? I've taken 1 by x square. So you think I will explain the difference of this graph. This is y equal to 1 by x. Domain and range we discussed about this. I'm talking about y equal to 1 by x square. So when I'm talking y equal to 1 by x square, you can observe domain is r minus 0. What about range of this? So it never be negative, right? It never be negative. It never be negative. Definitely will be positive. So here you can see the meaning here it comes 0 to infinity. You will come like this. It never be negative. Comes at 0 to infinity, right? The graph. Same thing. When it's a positive case, it will come same thing. You can observe here. The graph will come like this. When positive, it will come like this. Even when it's a negative, it's a positive only. Whether x is positive or negative, y value is positive. The graph will come like this. You can see that the graph will come like this. Right? Observe here. This is the position of this. I can write range of this. So this is clear. You understood this is the position of this. When I have taken the function, right? When I have taken this is the position of this. Here I have taken this is x-axis, right? Approaches like this. Now, here, these coordinate axes are called asymptotes. Asymptote. Both coordinate axes are asymptotes y equal to 1 by x. Even for y equal to 1 by x square, these are the asymptotes. What is the meaning of asymptote? Like, if a line touches any curve at infinity point, that line is called asymptote. If a line touches the curve at infinity point, that line is called asymptote. You can see it may touch at infinity point, but it may touch at infinity point. So here both the coordinate axes are called asymptotes. Here also I can say these two coordinate axes are called asymptotes in the para to the function f of x equal to 1 by x square. That you remember. Here asymptotes, both coordinates are asymptotes. Suppose now if I take 1 by x cube, like that, what will be the function of that? I can also think about f of x is equal to 1 by x over 2n minus 1. you can think about the graph of that. Just 1 by x power 2n minus 1. So if I take about the graph of that like reciprocal function, you can see here, I'm talking about 1 by x odd function. If we are talking by f of x equal to 1 by x power 2n minus 1, n belongs to n. It will come 1 by x cube, correct? The graph will come y equal to 1 by x cube, y equal to 1 by x power 4. If I take the graph, suppose x is equal to, I can write y equal to 1 by x we discussed, 1 by x square we discussed, right? If I take this one, then I consider like y equal to 1 by x cube, y equal to 1 by x power 4. I can also discuss about these two graphs, right? 1 by x cube, 1 by x power 4. I can discuss about this x cube and x power 4. So this is similar to this. So this is almost similar to this. If we think here, when x is increasing, the value is decreasing, right? That you keep in your mind. That one you can keep in mind. You can write the graph. Suppose the graph it will come like this. This is similar to y equal to 1 by x only. Why I have written 1 by x cube, I have written, right? Y equal to 1 by x cube, I have written. You should be careful. What about 1 by x power 4? It will come like this. It will come like this is this graph, and this will be this. It will come like this. Even I can also observe here. This also will come like this. It will come like this. The graph will come like this. The point of intersection. Be careful. The point of intersection. The point of intersection will be the same, right? 1 1. This will be 1 1, right? This will be minus 1 will get 1 by x power 5, right? Odd number. I've written odd number, right? 1 by x cube, 1 by x power 5. I can compare, I'm comparing 1 by x power x cube and x power 5. Here is the same thing I can reflect. This point I can write minus 1 minus 1. Minus 1 minus 1. Again, this is symmetric. Whatever the function, odd function, symmetric with respect to origin or opposite quadrants. Correct? This is symmetric with respect to origin, or we can say opposite quadrants. Now, if we take like reciprocal of given function, f of x is going to be combination of this. With that, I will stop now today. If I take x power 2n, n belongs to n. So you can think about 1 by x square, 1 by x power 4, how you will draw that? 1 by x square, 1 by, you think about 1 by x square, f of x equal to 1 by x square, f of x equal to 1 by x power 4. 1 by x square I have explained. Just you can think about 1 by x square, how will you draw this? This is 1 by x square. I explained, you will get like this. Always right, because always positive, going upward. Correct? Always positive. X approaches to plus infinity, this value y approaches to 0. X approaches minus infinity, even y approaches to 0. You will get this the graph of this. Again, if you increase the power, the value going on decreasing, right? So whatever the graph of this, it will come x power 4, it will come like this. Correct? You will get like this, right? The graph will come like this. Correct? You can see this is the graph of this, this is the graph of this, graph of that. You can observe here the value whenever approaching this one. This is the nature here. The graph will be the different here. You can see this is 1. Here you can think about this is minus 1. So always between 0 to 1 will be the variation, right? 0 to 1 will be the variation always. See 0 to 1 always you can observe here. There's a thing always 0 to 1 is the variation. But between 0 to 1, if increase, you can see between 0 to 1, if we compare x squared x power 4, you can see x square is more, x power 4 is less. The value is more, right? Between 0 to 1, you will get, if you compare between 0 to 4, you will get 1 by x square greater than 1 by x power 4. That's the reason graph will come like this. Almost I completed. Now, today I have completed in algebraic functions. I completed polynomial function, rational function. I completed polynomial rational function. I completed. Now, the next session, I am going to complete the second session. I will do that like irrational function, piecewise function. That is most important one. In third session, I will do trigonometric function, inverse trigonometry. In fourth session, finally I will complete in fourth session. I will do that logarithmic function, exponential function. In that, even inverse, all the functions. Finally, I will complete in fourth session. So thank you so much for visiting. If you like the session, you can like it, and the same time you subscribe my channel, subscribe and support me. Subscribe and support me to do more number of videos. I want to help you. Even if any particular topic, if you want, you can send me the chat box. Thank you so much. Please subscribe my channel. I will improve the quality and everything. I will improve. I will take care of. See you. Bye bye. You can subscribe my channel. Please subscribe my channel. If you like the class, you can give. You like it. Specific anything you want, you can also discuss with me in the chat box. I can help you. Fine. I have done almost basic things today. The next session is very good session. Don't miss the next session. Try to attend the next session. Better once if you subscribe my channel, you will get a notification immediately. That is I am sure I can help you. Fine. Fine. See you students. So subscribe my channel. Like this session. Next session I will inform you. Have a good day. Any particular doubts if you have, you can send me in the chat box. I will discuss any particular type of graph, anything you want. If you reply in the chat box, I can discuss that particular topic, any related graph, any doubt if you have, I can discuss with you. I can do that. Yeah. Can I end the stream now? So see you in the next session. Bye bye. Good night.